Hello, and welcome everyone. I'm here to talk to you today about workload identity for humans, a 12-factor approach. First, let me give you a little intro. My name is Vish Abrams. I'm the chief architect at Heroku, and I'm excited to talk about workload identity. So I think the best place to start is, what the heck is workload identity? And I put down the simplest definition that I could come up with, which is that it's a unique identity assigned to a workload for secure resource access. So in the case of an app developer, that means your application is your workload, and the secure resources you want to connect to are back-end APIs, databases, caches, other applications and services that your application needs to access. What about for humans? This is where 12-factor comes in. How many of you are familiar with the 12-factor manifesto? All right, it's been around for 12, 13 years. Essentially, you may have heard that actually we recently open sourced it, actually at the last KubeCon 6 months ago. And we are working with the community to update it and bring in some new ideas. So realistically, the thing that made 12-factor so powerful and has made it last so long is that at its root, what it's doing is defining a contract or an interface between an application developer and a platform developer, or an application and a platform. And what that means is that a developer who builds a 12-factor app can build an app that's portable across platform, and a platform can run any 12-factor app. So I like to think of 12-factor as the place where those interface definitions live. Here's an example. Today, most application developers never have to worry about TLS termination for their app. All they do is they listen on a port, and the platform magically directs traffic to their application. That allows them to build locally, using localhost on whatever port they want, and then when they push their application into the cloud or onto an internal platform, it just runs, and they don't have to worry about it. There are other examples that are not quite as standardized as this idea of port and TLS termination. Here's one, domain names. So many times the application is agnostic to where it's running, but there are certain cases where it actually needs to know what domain it's being accessed on. A really great example is OAuth callbacks. If you're doing an OAuth integration, the callback you have to pass to the remote OAuth server includes your domain name so it can redirect back to you at the end. Unfortunately, domain is not consistently provided across platforms. Some platforms may have a way to provide domain, like via an environment variable, but often what developers end up doing is figuring out what the domain is, wherever they're trying to deploy, and sticking it in a configuration variable for their application. That way, the application can be deployed to a staging environment or a production environment with different domain names, and the application still works. Realistically, this is often how applications deal with backing services as well, or connected resources. I mentioned earlier, databases, back-end APIs. So the most common practice is for the application developer to put something in configuration into the environment representing the location of the service they're trying to dock to. That way, they have a different database in staging versus production. They put in a different URI. The application still works. So essentially, the value of having this place to store configuration information gives you portability. You can run the same application, deploy it locally, deploy it in staging, deploy it in production, and all you have to do is modify a few configs. But when it comes to workload identity, and the reason that we need it is because there's a problem when we start talking about secrets. So this is a very common pattern. We see this across a lot of apps at Heroku, where people need authenticated access to a thing, and so they take their secret data and they store it in a configuration variable. And there's a few problems with this. So first of all, this kind of a model tends to favor long-lived secrets, because configuration tends to live for the lifetime of the application. So if your application is running for weeks between deployments, that secret will stay the same for the entire length of the application. Secondarily, it's hard to keep in sync. If your service provider who's providing your database gives you a new database password, and you have to go update your application, or that database class password gets leaked and you need to tell the service provider to update the password, you then have to orchestrate deploying the new credential in one place and the other place at the same time. The other issue is that in this form, it's easier to accidentally expose the secrets. And partially this is because the environment tends to get logged in a lot of places. The fact that it's in multiple places is a problem, the fact that it's often logged. And so what we see are these sort of cascading failures where the secret is easily exposed, and then because it's easily exposed, it has to be rotated. And when it has to be rotated, you have to worry about these other problems of keeping it in sync and being vulnerable for a long time as that rotation goes through. I've heard stories of companies with hundreds or thousands of microservices that have a large credential leak where they have to rotate all of their applications at once or over a period of multiple weeks. And during that intervening time, it's not a very fun time for the security team at that company. So, what I'm going to talk about today is how we could build something better. So what if we could have short-lived, connection-scoped, workload identity credentials managed by the platform that are standard everywhere? Let's go through those pieces in a little bit more detail. So when I say short-lived, that means 30 minutes, 60 minutes for the credential to rotate. It minimizes the risk of exposure. Connection-scoped means that it's not one credential for an application for everything that it talks to. It's a different credential for the application for each thing that it talks to. And the main value of this is you don't want to have what's called the confused deputy problem, where service A is talking to service B with their credential, service B takes that credential and goes talks to service C and pretends it's service A. So that's a risk of exposure as well. We want it to be platform managed because that's the value of standardizing on something like this. It means the application doesn't have to worry about the complexity. The developer doesn't have to figure out how to do workload credentials separately everywhere they want to deploy their application. And standardized means that it's portable across platforms and across environments. So let's talk about how we might get there. So the first step is let's standardize the way that we store credentials in the environment. So that basically, very simply means we have a standard way of representing a thing that we're talking to and the credentials associated with that thing. It could have a type like user, password, secret, et cetera, associated with it. The next step is to make the platform responsible for synchronizing the secrets between the front end and the back end services. So we have a secret, we change it in one place with the platform, it's exposed to the front end and the back end, it's shared. We haven't gotten to short-lived yet, so that's next. The next thing we can do is replace those usages of secrets that are username and passwords or secret sharing with a different type of credential that's short-lived. Now, we don't have to reinvent the wheel here. I'm not inventing a new type of secret. That's kind of like building your own SSL. Nobody wants to do that. You don't build your own crypto. We all know this as developers, right? So we can use some of the existing standards. For example, in the cloud native community, we have SPIFFE. There's two standards already there. There's the workload ID represented with the JWT that's OIDC based, and there's a certificate based one, X509. We can just use one of those. So in the example of OIDC here, the platform provides the token to the application in a known location that it can share in the credential in the environment. And the application is responsible for loading those credentials and using them to make requests. And then the platform also provides the back end with the information on how to validate those credentials so that it knows what is connecting to it. But there's a couple of problems here. The first one is that if you've ever tried validating OIDC while it's a standard, is somewhat complicated. It's not exactly the most straightforward thing. You have to remember to check the expiration date. You have to download the JSON web key set. You have to cache it because it gets inefficient if you're downloading it every time. You have to deal with network outages. You have to make sure your clocks are in sync. There's a lot to do here. The second problem is if we start thinking about X509 as the other option here, is that the most common way to validate an identity between applications using X509 is to use mutual TLS. And in order to configure mutual TLS, your backend service needs to be the one terminating TLS. It can't actually use mutual TLS unless it's terminating the TLS connection. And as we mentioned earlier, in most platforms, it's not the backend application that does that. It's the platform. So it really needs to be in the platform that TLS termination and identity validation happens. So what does that mean? The alternative here is to proxy the incoming request between the front end and the back end. So when you configure identity for your front end and back end application, you're providing credentials to the front end and you're sticking a proxy in front of the back end. Maybe it's in your already existing proxy that you're using to terminate TLS. And that proxy is responsible for validating the incoming credentials and providing an identifier to the back end application so it knows where the request came from. And it can do this in a standard way, like providing a header. So, summarize, on the sending side, the application has to read the URI of the service from the environment. It looks for a matching credential. It reads the token, and it sends the token in an authorization header. There is one more bit that it has to worry about, which is refreshing the token. So I mentioned this token is short-lived. So there are a few different ways to accomplish refreshing. The probably most compatible and obvious way to do it is to watch the token file using iNotify. And whenever it's updated, you get notified and you can reload it. But there are other ways that would work almost as well. So for example, you could reload the token every time you're about to make a request. If the requests are infrequent, that's not such a bad option. You can also parse the OIDC token if you want to do a little bit more complex integration and check for expiry coming up soon and refresh it. And then the fallback option is you can try and make the request, get a 403, and then redo the request with the new token the next time. On the receiving side, it's much simpler. The only thing that the receiving application has to do is check for client ID in the request header, and it can trust it. So, going through these steps, you might think, well, what about step 5? Like, we have a proxy on the incoming side. Wouldn't it be much simpler to have a proxy on the outgoing side as well? And I'm going to warn you that there are dragons here. This is complicated, and it's not completely out of the question that something like this can work, but there's a lot that you have to think about if you do an outgoing proxy. First of all, you're man-in-the-middling every request. So if you're making if the user application is making a request to a known endpoint that has its own SSL cert, you're going to have to serve up an alternative SSL cert that doesn't match the actual one because you don't own the SSL cert from, for example, Google.com. Additionally, often there's retry loops that happen in the proxy which can hide reconnections and retries from the front-end application, and that means that suddenly there's extra latency that's been injected that it doesn't know about, and that can cause failures. So the good news is, if we standardize on this approach of having a URI and then having an associated credentials, if people manage to build proxies, if a platform does build a proxy and they're comfortable with it and it works, they just don't provide a credential in the environment and the client application works the same way. It doesn't need to worry about the connection, it just knows that this is authenticated by the platform. Okay, the next big challenge is there's a huge chicken and egg problem, and this happens whenever we want to update standards and move to something new. In this case, application developers want something better, platform developers want something better, but the application developers can't move until the platform side moves, and the platform side can't move until the application developer side moves. And so the approach that we've come up with for this is to create a CLI which can act as a platform if the platform doesn't support this kind of feature already. I'd like to think of it as a polyfill. So borrowing something from web standards and from browser standards, often when they're introducing new features in CSS or JavaScript, they will provide an implementation that's not native, that might be a little bit slower to implement the feature so everyone can start using it until the browsers are updated to support the feature natively. So the idea of this is the same. And the advantage of this is one of the biggest challenges of this kind of a system is you don't have an identity locally. So when you're in development mode and you're trying to connect to a backend service, you need an identity because when you're in the production or a staging, you need an identity. And so this solves that problem by allowing you to have a faux platform running on your local machine. And I'm going to give you a demo of how it would work. And I'll say that you're in luck because usually all of my demos would be just a bunch of curl commands in a terminal. But thanks to vibe coding, I actually have a front-end and back-end application that you get to see that look a little bit nicer. So let me start by just running the front end and back end application. And there's the front end. There's the back end. OK, so basically, I mentioned about the front end and the back end. They're not running under the Factor CLI right now. They don't have the polyfill. So at the moment, if I make a request and I don't pass in the client ID, what you'll see is the back end is giving me unauthorized because it doesn't see X client ID in the header. Whereas if I make a request with client ID, then it says, oh, yes, I know who that front-end application is. Now, that's not exactly what we want here, because any client could just pass in X client ID in the header, and then it would be authenticated. So what we actually want to do is, wrong way, run this application with the Factor CLI instead. Give it a little refresh. Now, if I run it without client ID, I still see unauthorized. And if I run it with client ID, I see unauthorized. So now there's a proxy in place between the front end and the back end of the application. The back end application is identifying the credentials being sent by the front end application, which in this case are none, and then passing that client ID header, if it exists, to the back end. Back end doesn't see the client ID header anymore, and so it says, nope, you're not authorized. And then on the other side, let's do the same thing. Let's just run this front-end application in the Factor CLI. And reload it. And now when now you'll notice it says that I have a token loaded. So if I make the request without the token, it's unauthorized. But if I pass the token in, it's authorized. Okay? So the really cool thing about this is that the difference between running your application with and without the polyfill is essentially a couple of extra words that you enter on the command line. Now let's briefly just look at what was the code that I had to do to make that work. So on the sending side, here it is. We load the backend credentials. We check the file that it's pointing at. We load the file. We start a watch to see if the file's changed. And then we're just taking that data from the load, and we're passing that in every request to the backend. Backend, even simpler, right? All we need to do is check for X client ID and return unauthorized if it's not there. So we've got something that's pretty simple and that can be used. But let's go a little farther. So briefly, the features of this Factor CLI. And by the way, this is all prototype for discussion. One of the things that we're trying to do is start this conversation by introducing an identity factor into the 12-factor app manifesto and trying to get the... So if you disagree with some of the details, I don't really like X client ID as a header type, come help collaborate with us and figure out what it should be, right? We're not attached to the specific details of the implementation. I'm trying to get across the idea of us all as a community getting together and finding a way to do this so that every application developer, every framework can implement it the same way, and we don't have to have this same problem that everyone is solving at every company independently. So workload identity can manage local OIDC. It can use Auth0. It can use Kubernetes service accounts. Incoming validation via a proxy. It'll automatically load your end file and detect if it's changed to give you an easy way to change the config of your application. And it actually has another interesting feature, which is in local development when you need to do incoming requests or you need to provide the JSON web key set, you need to be exposed on the internet. So it can start up ngrok for you and expose your local application on the internet so that you can do those point-to-point connections remotely. Okay, one more demo. I was going to do this live, but I was informed that depending on the internet is tough, so I'm just going to talk over it. So the next step is let's take the backend app and deploy it on an actual platform. I'm going to deploy on Heroku because I work there. And in this case, Heroku doesn't support this yet. But I can just add a build pack, which I've created, which will wrap your application up automatically in the Factor CLI and run it. So we're using the Factor CLI remotely as a polyfill as well. So we're starting up the application. As it's building, all I'm doing on the left side is, now that I know the URI of the backend application, I'm setting an environment variable over there on the front end application. And then the build's going to go through. You can see it's building from my source code. It's just a pretty simple Go application, pulling in all the dependencies, building it up, wrapping it with Factor. And then I'm running the front end application using the Factor CLI on the front end as well. And you'll see there that ngrok is exposing the application so that the receiving side can validate the tokens that I'm passing in. And in a moment, we'll be going and seeing that application in action in very similar to what we saw before. So there's the front end. Here's the back end. Again, make the request. And if we request without a token, we're getting unauthorized, and we're requesting with a token. Oh, wait, we're also getting unauthorized. What happened there? OK, well, the issue is that I configured the front-end application with the back end, but I didn't configure the back end with the front end. And so I copy the token values out of my nice little front-end application, and I set a configuration option on the back-end application telling it what the front-end client creds that it needs to validate are. And then what we'll see when we go back is that we refresh the back end. Now, have you noticed that when I refresh the back end here, we lose the old requests? I'm going to talk about that in a second. So make the request again without a token, now with a token. We see that it's been validated, it all works. So the same thing I was using locally, I just used on Heroku in 3 minutes, very simple. Now, about this back-end piece not working, where it's about the reloading of the display on the back end. Wouldn't it be great if we could store the previous requests somewhere, maybe in like an object storage system that's a remote application? And so the extra little bit we're adding here is the backend service also has a set of credentials, and it can use those credentials to talk to a remote web service like AWS. What you saw me doing in there in the IAM console is configuring AWS to match a role to the token that's being provided automatically by the Factor CLI. I have to set a few environment variables, like the role ARN here, and then I can just use the AWS SDK with the web identity token file to store things in S3. And so now I can make new requests, and on the back end, these are going to be stored in S3. I can go over and restart the application. And we'll see that now when I reload the application, because it has stored the requests in S3, it'll reload them from S3 on the back end. Again, as a developer, the code that I had to do to write to make that happen was very minimal because I had a token that was provided to me by the platform. So you can see some value here, I hope. But there are a few other challenges we have to worry about. First of all, connecting to cloud services. So every one of the major cloud services, or most of the major cloud services, provide a way to use an Open Identity Connect token to connect to them. So S3, Google Objects, AWS Blob Store, or sorry, Azure Blob Store support this, but setup is hard. You saw I had to go in the IAM console and do some extra steps. It's not exactly perfectly straightforward, and the SDK support is mixed. Many times you have to do some very complicated steps with the SDK to actually get it to use the token properly. So that could be a lot nicer of an experience. Another problem is non-HTTP services. So it's possible to configure Postgres, for example, to validate an OIDC token, but it requires installing a PAM plugin and then using a PAM OIDC library. It's pretty janky. So when we're trying to pull in, we'd love to be able to use the same method to connect to everything. So if we're trying to pull in these non-HTTP protocols, we might need something else. We either need to support X509, we need to get these services to update and natively support validating OIDC credentials, or maybe we use a custom proxy in that case. Another thing that I haven't covered at all is policy, and that was intentional. The way that I'm thinking about workload identity is separating authentication from authorization. And you can still use the existing systems that are in place, like Open Policy Agent. Once you're at the application level, you can validate the client ID and then send it off to something else, or use an Open Policy Agent library to validate and decide what to do inside the application once you know who is talking to you. Little breadcrumb for the future. So one of the challenges here is that everything I've talked about assumes that you kind of have one platform that's managing both things. Otherwise, you still have the synchronization problem between platforms. So there's actually a prototype specification and example called CloudPipe, also in the 12-factor repository, that's trying to get towards the next step on this, which is how do you get the platforms to agree to make the setup easier? So wouldn't it be great if I didn't have to go in the IAM console and click through a bunch of things manually, and I just had an API that I could say, this thing needs to talk to that thing, and it does all the setup for me automatically. So, quick recap. And after the recap, we might have a couple of minutes for questions, so if you have anything, get ready. Okay, so I'm proposing short-lived connection-scoped credentials for secure workload identity with a standardized interface to simplify development across platforms. That identity should be managed by the platform, which removes the complexity of managing it from the apps. Developers focus on code and not credential management. A couple nights ago, I was having a conversation, and I had an insight that some of the most costly problems in computer science actually aren't the really hard problems. They're the problems that are just a little bit hard. And the reason is because if the problem is a little bit hard, nobody really goes and figures out how to solve it. So when you take the aggregate cost of small problems across an entire industry, it's super high. You have someone in every single company, trying to figure out how to do identity. They solve it, it sort of works, it's hard, they set up their credentials, they kind of have it working, and then the next person has to solve it, the next application has to solve it. And so, yes, you can figure this stuff out, there are solutions that exist for these things, but it's not easy, and therefore it's very costly. So I think if there's one main takeaway, that's what I'd like to convey. Secondly, come help. We want to collaborate with everyone on making this better. Let's get this standardized and let's get everything supporting it so we don't have to worry about this problem anymore. So we have, I think, maybe 3 minutes for questions. If anybody wants to ask one, feel free. I put a QR code for our 12-factor Discord. If you want to come talk with us, collaborate, work on things together, we would love that. Anybody have anything? Got one? There's a mic there. You might have to, unless you can yell.
Thanks very much for the talk. Always impressive to see Heroku also coming up in a way and coming back. The workload identity piece of work, is that with the new platform?
Is that
applicable with the new platform you're launching?
Not yet. So our goal is to get the community support around this idea, and then we'll introduce it to the platform. That's why we built the polyfill. But we don't want to build something that nobody else thinks is the right way to do it and doesn't adopt, and then have to go rebuild it again later. So we're trying to get community support first before we implement it internally.
And you're not using any part of that within Heroku, or maybe between Heroku and Salesforce? Or
we have an internal implementation of some of this that we use to talk to some of our AWS services on the back end, and it's actually been great for us because it's got us a whole bunch of AWS credentials out of many of our systems, which is much safer. But we don't have an external offering like this yet because we want to get the standardization done first.
And that's all SPIFFE based?
Our internal one just uses raw OIDC, not SPIFFE OIDC, but yeah, could be.
Thank you.
You're welcome. Okay, I think I'm about out of time. Yes. So, thank you. I want to invite everyone to come to our happy hour this evening. If you haven't registered, there's a QR code. It's going to be a lot of fun. We can talk more about 12-factor and workload identity there. Thank you so much for the time.